Okay, good morning. So the next topic of the lesson is trigonometric identities. So we studied trigonometric equations. Now we want to talk about trigonometric identities. So if you remember, I already talked about what is the difference between an identity and an equation, yes? For example, I would say that sine 2x equals to 0, comma 5 is not an identity because this is not the case that it is always true. We have to find appropriate values for x so that the left-hand side becomes equal to the right-hand side. So this is an equation, yes? But do you remember we had this formula from the very early lessons, so that sine of any angle theta to the power of 2 plus cosine of the same angle to power 2 is equal to 1. So this equality does not depend on the value that I choose for theta. Whatever I choose for theta, if I calculate the left-hand side, it becomes always equal to 1. So this is an identity. So if I want to say it in a more informal language, I would say that identities are formulas. So the formulas that are always working. So in an equation, so what are the similarities between them? In an equation, you have equality sign. An identity, you also have an equality sign. And then you have some variables in an equation, some variables in an identity. But the difference is that an equation is sometimes true, sometimes false. And we solve it, meaning that we want to find all possible values of the unknown for which this equality holds. And here for identities, we don't say solve it because it is always true. We say prove it, prove or show. Okay? So we have already shown this. This is the most fundamental, probably this is the basic identity in trigonometry. So any angle, if you take sine of it, square it, plus the same angle, cosine of it, square it, it becomes always equal to 1. Yes? So is that clear? What is the difference between an equation and identity? Okay, so today's lesson is that we want to learn how to prove a little bit more complicated identities. For example, do you remember in Math 1C or 2C, this is an identity. So a plus b squared is a squared plus 2ab plus b squared. We prove it once and use it whenever we need it. Okay, why this is an identity? Because the left-hand side for any choices of a and b matches with the value for the same values of the right-hand side, yes? So these two, this is an identity that we were able to show. We can prove algebraic identities, we can prove trigonometric identities. When we have trigonometric identities, it means somehow we have an identity and somehow trigonometry is involved in it. So this is not a trigonometric identity, this is a formula which is valid for all possible choices of A and B, but we call it an algebraic identity. This one is an identity, but involves with sine and cosine, so we call it a trigonometric identity. Okay, so today's lesson is more or less we want to solve a little bit harder problems under the title of trigonometric identities. There is no teaching here, but I have to present a little bit examples so that by solving them, so you can get experience how to do these problems. But before that, there are some standard problems, so I want to solve first. So I want to give you some examples. They are also expressed in the book, and they are also important in the national exam so that you can use this formula to answer it exactly. So let me start by some of them. So example, the first example, I want to give an example that uses this formula to answer the question. So I would say let theta be an angle in the second quadrant such that let us say sine theta is minus 1 over 5. Oh, sorry. In the second quadrant, psi cannot be negative. Determine the exact values of cosine theta and tangent theta. Okay, so that is a standard question. I want you to know the format. An angle with the final point of it, so the quadrant at which this angle lies is given, sine is given, the other values are wanted. So cosine and tangent are wanted. And then when I say exact, because I have seen some students solve this problem like this, they say that, okay, even if the calculator is allowed, when you see exact, you shouldn't do it like this, because when I say solve this problem, many people say that, okay, theta is sine inverse of 1 over 5, and I don't know, they put this in the calculator, get a number, and then take that number, calculate cosine, and calculate tangent. In principle, this is not wrong, but that will give you only approximate values, not exact values. Okay? So that's why when I emphasize the exact, even if that is coming in that part of the exam in which the calculator is allowed, if you do it in that way, you will not receive any points, because that's not the exact value, that's just the approximation. Yes? Even though technically speaking, that is not wrong. Okay, so how should we solve this typical problem? You immediately use this. Okay, so the solution will be like this. So what we write, we say that, okay, for any angle, including this angle, sine of that angle squared plus cosine of the same angle squared is 1. And sine theta, I don't know theta, but sine theta is given to be 1/5. So instead of sine theta, I put 1 over 5, and then I have a power of 2. And then you see that cosine theta is unknown to me. Yes? But then I have to solve this and find this unknown. Okay? So what happens here, this becomes 1 over 25 plus cosine squared theta equals to 1. I need to isolate cosine, so I move this to the other side. It becomes 1 minus 1 over 25. If you want to calculate, instead of 1, you write 25 over 25, and then minus 1 over 25. So it becomes 24 over 25. Yes, so that is cosine theta squared. But the question is asking you about cosine. So what is cosine? Remember, when you take a square root to find an unknown, you have to put plus or minus first, then a square root. So it is 24 over 25. Yes? Okay, but this can be written as plus or minus a square root of 24, and the square root of 25 is just simply 5. You can keep it like this, but the square root of 24 can be written a little bit simpler. So you can write it as a square root of 4. This is enough, you don't need to continue, okay? But in case you want to simplify, then it becomes square root of 4 times square root of 6. Square root of 4 is 2, so this becomes 2 square root of 6. So it is better to simplify if you can, okay? So 2 square root of 6 over 5. Okay, but I haven't used this information yet. Theta is an angle in the second quadrant. Okay, so cosine theta, as far as this relation is concerned, has two solutions, one with positive sign, one with negative sign. But because it is explicitly mentioned that theta is in the second quadrant, you need to visualize, is the cosine theta positive in the second quadrant or negative? It is negative, yes, because cosine is the x coordinate, yes. So if you have the unit circle, if you have an angle in the second quadrant, so x and y, so you immediately see that the x coordinate is negative, yes? So an x coordinate is cosine. So this means that you need to write it down, okay? Since in the second quadrant, cosine theta is negative, then Therefore, cosine theta is what? -2 square root of 5, square root of what was that? 6 divided by. So this is the value, the exact value for cosine. If you use the method that I told you, you will get a number which is approximately equal to this one number. But because this exact value is wanted, using the calculator is not possible. Okay, and when I found cosine, the answer to tangent is simple because we have another formula which is also famous. What is the formula? Which relates tangent to sine and cosine. Do you remember that? That is sine theta over cosine theta. So tangent is not an independent identity. Whenever you have entity, is not an independent entity. Whenever you have sine and cosine, you divide them, you find tangent. Okay, so I found tangent here is sine theta, cosine theta. Sine theta was given in the problem from the beginning. Cosine theta, I got it to be -2 square root of 6 over 5. And then this 5 and that 5 were simplified. So this means that tangent of theta is equal to -1 over 2 square root of 6. And that is tangent theta. Yes? So this is a typical problem. I want to somehow, I might store it, but it doesn't mean it is hard. It means that it's essential and easy. Okay? So remember, if sine is given to you, in principle, you can calculate cosine and tangent using this trick. I will not give you another example. I could have given you cosine, and then I ask you the same for sine and tangent. Of course, it is clear. You start with this again. What do? You replace cosine with the given value, you find sine, and then you divide them, it becomes tangent. So I will not repeat the example. But I will repeat an example if I give you tangent and I ask you to find sine and cosine. Okay? So, example. So I would say, for example, let theta be in the fourth quadrant such that, for example, tangent of that angle theta is given to be -5. So you know that sine and cosine cannot go beyond 1 and -1, but tangent doesn't have any limitation. It can be very negative number or it can be very positive number. So there is no limitation for the value. So I couldn't say that if sine theta is -5. That doesn't make sense at all. Okay, but for tangent I don't have any problems. So let theta be in the fourth quadrant such that tangent of that angle is -5. Determine the exact So again, I emphasize here the exact values of sine theta and cosine theta. Now, what do you think I will do here? This is a little bit more tricky than previous one. Because the identity that I have involves sine and cosine, but I have information regarding tangent. Yes? So that is not immediately useful. Okay, and this is the only relation that is left for me that relates tangent to sine and cosine. Okay, so this time we start with this one. So we say that, okay, tangent of theta is equal to sine theta over cosine theta. But what do I have? Instead of tangent, I can put the number given. So this is given to be -5. So because this is -5, I take this off and put -5. It becomes sine theta cosine theta. Of course, it is not possible to immediately answer this question because I have one piece of information, I have one equality, but I have two unknowns. So it is not enough to solve it unless I use another piece of information. And hopefully you understand what to do. For example, let us multiply everything by cosine theta to get rid of fractions. So this means that minus 5 cosine theta is sine theta. But I cannot go further. But this is good because I have two unknowns. One of them is sine, the other one is cosine, and I was able to use the information to find something about sine and cosine. This is one piece of information. What is the another piece of information? Because I need to solve for two unknowns. Sine is unknown, cosine is unknown. I need two pieces of information in order to be able to find two unknowns. One piece of information is this equality that you see. It tells you sine theta, whatever it is minus 5 times cosine theta. This sentence that I just read in English, that is just one piece of information. Yes? What is another piece of information? Yeah? So another piece of information is on the board, isn't it? Yes? Yeah, that's also a piece of information because this is also telling you something about sine and cosine. It tells you that if you take sine squared, cosine squared, and add them, it becomes 1. That is also an English sentence providing a piece of information regarding sine and cosine. So that should be useful. So what does it mean? It means that you need to solve a system consisting of two pieces of information. One information is that sine theta is minus 5 cosine theta. Another piece of information, which is always true for any angle, is this one. Yes? So if I ask you what do you see on the board, this is a system of equations, of two equations in two unknowns. One unknown is sine theta, the other unknown is cosine theta. Okay? How can I solve the system? Yes, please.
You move cosine to the other side and then combine the equations.
It is not a good idea because this is not a standard one. If let us just do that, I want you to feel why it doesn't work. So if I take this one, and the second one is this one, you know, if you want to understand it better, let us in your head, let us take sine theta to be x, let us take cosine theta to be y. Then what you are saying is this equation, x plus y is equal to 0, and x squared plus y squared is equal to 1. Yes?
You move y to the other side and then
So y was already the other side, yes, wasn't it? So it is 5y. Yes?
you should move y5 to the other side and then y2 to the other equation and square root it so that there's one x that is the same on both sides both equations. And then you have
I understand what you say. First of all, so it means that you don't need to move it to the left because then you want to move it to the right.
yeah.
So if you want to move it to the right, let us keep it right.
Yeah.
But what you are saying is that using this one, I move this to the other side and take a square root.
Yeah.
Technically, what you are saying is right. It is not good. Why is that? I want you to understand because if you say, for example, I move this to the other side, and then what happens? I have to take a square root, yes? But when I take a square root, remember, you have to put plus or minus. Okay, and then that is correct. And then instead of sine, you put that one, and then you solve one equation and solve it. First of all, technically, it is harder than a better method. First of all, you need to solve a root equation, including square roots. So secondly, you have to solve two of them, one with plus sign, one with negative sign. But technically, what you are saying is not wrong. But I want you to understand between the legal things, you have to choose the efficient one. And this is very important because if you don't choose the efficient one, then might be you will not even able to solve it. So technically what you are saying is completely okay. So it means that you understand what's the meaning of solving a system. But okay, can you use the other idea? Yes? Yeah, isn't it easier? Because you are telling that sine theta is minus 5 cosine theta. In the second equation, I can take this off and put this expression in. Yes? And then everything will be in terms of cosine. Because how many unknowns you have? You have two unknowns. in order to solve a system, you have to reduce a system with two unknowns into an equation with one unknown. The way that you did it was correct from a strategic point of view, it was correct. But from technical point of view, it was a little bit subtle. So this is why we changed the strategy. So this is the technique that we use, okay? The tactics, yes. So what we do, yes, I take this sine theta off, because you are telling me sine theta, whatever it is minus 5 cosine theta, so I can take it off and put minus 5 cosine theta here. So then what happens? It becomes minus 5 cosine theta squared, and then I copy and paste the rest. So it becomes plus cosine theta squared is equal to 1. And in this one equation, you have one piece of information, but you have only one unknown, and the name of the unknown is cosine theta. So that's enough. So we should, in principle, be able to solve it. So then what happens? I raise it to power 2. It becomes 25 cosine to the power of 2 theta, and cosine to the power of 2 theta is equal to 1. But now we know that what happens, this becomes, let me write here. So this becomes 26 cosine theta squared is equal to 1. So this means cosine theta squared is 1 over 26. Cosine theta is what? Sorry for the mess a little bit. 1 over square root of 26, because the square root of 1 is just 1. Yes, so these are the numbers that I get. But again, you need to see which one is acceptable, positive 1 or negative 1, then you have to use this piece of information. So theta is given to be in the fourth quadrant, yes? So can you imagine in the fourth quadrant, cosine is positive or negative? Positive, because cosine is the x-coordinate, and the x-coordinate in the fourth quadrant is positive. So you will say that since in the fourth quadrant cosine theta is positive, therefore which one we choose? We choose cosine theta to be the positive one. So this is so you see that it was a little bit more, but you need to see that the problems will be solved always the same way. If sine or cosine is given, you will start with this identity. If tangent is given, you will start with that identity, and then you set up a system to solve that, okay? Might be there are other ways, might be we can see some other way for this one, but this is the standard one. I think it's good. And then after you found sine, after you found cosine, I want you to answer sine. So how do you calculate sine? How do you? Yes? Yes? Yeah, it is minus sine. You are telling me it's minus 5 times cosine. And I know cosine, so I multiply it by minus 5. Yes? So it's minus 5 over square root of 26. And here, automatically, the sign is correct. Yes? Do you expect to get a negative number?
Should you multiply?
Pardon?
Should you multiply the tangent with the cosine?
You can also do that. But why should I do that? Yes, I need tan sine. You can also do that. My goal is to find sine. Sine is minus 5 times cosine. Cosine is this number, so I just multiply it by minus 5. Yes, you can solve it like this. You can say that, okay, sine theta is tangent theta cosine theta. Yes, that's the same thing. Tangent is minus 5. And then you multiply it by cosine, you get the same thing. Yes? So, I don't know, am I confused or not? So any questions? Is that answer, do you expect to get a negative value? Because theta is in the fourth quadrant. In the fourth quadrant, y value is negative. So yes, the sign that you are getting is expected already. So any questions here? So these two problems I want you to know. So these are standard problems that we use this trigonometric identity and that one to solve it. But there are other trigonometric identities. Let me give 2 examples from the book. That is good. And then we can solve a little bit more interesting ones. So, example, prove or show, let me use the word prove, the following identities. Yes, so number one, this is given in the book. So sine theta plus cosine theta. Was it that? No, they have put a minus sign between. And then to the power of 2 plus 2 sine theta cosine theta is equal to 1. Okay, so be careful. This is similar, don't get confused. I am asking you prove the following identity. It means that somehow the responsibility of this one to be true is mine. And I am telling you prove this is always true. Okay? So I'm asking you to prove that for any value of theta that you choose, if you calculate the left-hand side, regardless of the value for theta that you choose, the answer is always 1. So I am claiming this is always 1. So when I claim something, you should be able to prove it or disprove it. But it is meaningless to say solve it. Yes? I want you to understand the difference between these words. Okay, so what should I do? The way that we usually prove identities is like algebraic identities. For example, I prefer to start from one side and do calculations and little by little reach to the other side. And as a rule of thumb, it is always better to start with the side which is more complicated because you want to make it more organized, you want to simplify it. For our brain, it is easier to simplify things rather than to make things complicated, yes? So it's better to start from the place that it is more complicated and little by little reach to the other side. So here in this case, I agree, hopefully you agree with me that the left-hand side is more complicated. Okay, and I told you there is no lesson that I can tell you. So what do you think I will do? I want to do some legal mathematical calculations on this expression so that it will take me from this side to that side. For example, there is no formula for this that you know. Sine theta minus cosine theta, we don't have anything for that. Or I don't know, 2 sine theta, cosine theta, we don't have anything for that. So there is only one alternative left for us, and what is that? Yes? It's not conjugate, but what should I do? I need to expand this, open up the pair of brackets, yes? And that is the algebraic identity. So algebraic identities, for example, this one is a squared plus 2ab plus b squared. We know it from Math 2C. But what does it mean? It means that whatever number you choose for a, whatever number you choose for b, the left-hand side can be opened up like this. And you need to read it. The message behind this formula is what? If you have two numbers added and you want to square it, you can square the first one plus 2 times the first one times the second one plus the second one squared. This is the message behind this formula. So this message can be used here as well, yes? But this one is playing the role of that number A, this one is playing the role of that number B. So if I have two things subtracted, if I have two numbers subtracted and I want to square the result, I can square the first one, yes? I can write 2 times the first one times the second one, but this is negative, so it becomes minus 2 sine theta cosine theta, and then plus the second one squared. Yes? So if I ask you what I did, I just used that algebraic identity to open this up. Is it applicable here? Yes, because this is valid. Let me write it with the negative sign here. So this is valid for any numbers a and b, including sine theta and cosine theta, which at the end will be numbers, yes? And then, of course, there is other term involved. I have a plus sign. I have to copy and paste the rest, because there is nothing I can probably do with this part. Okay, then you see what happens, yes? You can see that this expression that appears after expansion is exactly this expression, but there is a good point. The good point is that one of them comes with a negative sign, the other one comes with a positive sign. So no matter what theta is, this number and that number are equal, but the signs are opposite, so when I add them, it becomes 0. So this is cancelled out. And I am left with these two terms. But this is also famous. I know for any angle theta, sine theta squared plus cosine theta squared is 1. And 1 is the right-hand side. So I was able to start from the left-hand side and do some legal mathematical calculations and simplify things little by little and reach to the other side, independent of what theta is. That is the meaning of the proving of this idea. Is that clear? The second example in the book, let me also use that. So I would say this is the identity. 1 plus tan x to the power of 2 is equal to 1 over cosine x to the power of 2. Of course, here there are some limitations. And by the way, when we say prove the following, I mean prove the following is true in the domain of applicability. What do I mean by that? For example, if I take theta x to be 90 degrees, if you read the table, cosine of 90 degrees is 0, and 1 over 0 is not defined. So when I say prove this identity, I don't mean it works if x is 90 degrees. I mean it works whenever they are defined. Okay? So if cosine x is not 0 and tangent x is also defined, I am claiming that this one is always equal to this one. So you have to respect that. This is usually not mentioned explicitly in the problem. But I want you to know, when we say we prove this equality, that this is always true, it's a little bit of lie. That doesn't mean always true. It means that always if they are defined. Okay? But of course, that is a few number of exceptions we don't need to be worried about. Okay, so let us solve this one. So what can I do? What do you think I will do here? Which one is more complicated, do you think? Yeah, I don't know. Might be the left side. Okay, so let us start with the left side again. For 1, we cannot do anything, so let us just copy and paste 1 here. Yes. But what is your suggestion for tangent x squared? What should I do? One thing is good to think about. You see on the right-hand side, you don't see any tangents involved. Yes? On the left-hand side, you see tangent. These are the things that might facilitate the way that you understand what to do. Left-hand side involves tangent. Right-hand side involves cosine, but not tangent. So that would be a good idea if I can get rid of tangent in favor of cosine. Yes? Yes?
Can't you write it as sine squared divided by?
Yes, we can do that. So that's exactly what I want you to see why this is correct. So we have tangent theta is equal to sine theta cosine theta. From now on, I will do this part quickly, but when I raise it to power, for example, k, it means that I am raising this to power k. And then you know that if I have a fraction raised to power k, it means the numerator is raised to power k, and the denominator is also raised to power k. Okay, so when you write tangent x, you can simply write sine x over cosine x. And if I ask you tangent to the power of 2x, you don't need to write so many things. You just simply write sine to the power of 2x, cosine x to the power of 2, okay? Quickly. So you don't need to justify that this power goes here and there. So you are right. So what we do here, when I see tangent x squared, I write it as sine x squared divided by cosine x squared. This is the first thing that we do. It is not that bad, because at least what you need on the right is cosine x squared, and you see it. So you have some hope that if you do it correctly, you will reach to this side. Yeah, so that is something like this. Okay, the next thing is that you see this is only one fraction. But here I have one fraction, and some simple number. I have two things added, but I need one fraction. If I have two things added, one fraction, this is also a fraction because you can imagine 1 over 1. If I have two fractions added and I want to have only one fraction, that is the common denominator, yes? So what you do, instead of 1, you write what? You want to write it in a way that you see this denominator appears here. So how should I write it? Exactly like this. For example, if I ask you add 1 to 2 over 3, what do you do? Instead of 1, do you write what?
3 over 3.
3 over 3, and then plus 2 over 3. Why this is good? Because firstly, 3 over 3 is indeed 1. Secondly, now the denominators are the same, so I can write the same denominator and add the numerators, yes? So that's the reason, instead of 1, I write cosine x to the power of 2, again cosine x to the power of 2. Plus, I copy and paste the second term. Yes? Okay. In principle, I want you to understand, in principle, I could write for 1, I could write 5 over 5. I could write sine x over sine x. Why did I choose this one? It is clear, because I want to write it in a way that, firstly, it is equal to 1. Secondly, it has the same denominator as the second one. And that's the only option, yes?
Is that possible to just skip that one and just multiply everything by cosine x power 2?
No, don't do these things, because that is working only for equations. So you are just multiplying things and reach to something that is correct. I told you several times, this is something we don't know. If you start working with this, it means that if this is true, then this is also true. So you prove P, then Q, and set it for Q, then P. Yes, and they are not the same. Okay, this might help. This is a scratch work thing. If you think that will help, you can do that. But you have to be careful. If you start using this and reach to something which is true at the end, it means that you are taking this for granted and proving something that you already know is true. This is not a healthy logic, yes? Okay, so what you do, now the denominators are the same, so I can take the common denominator here, and of course you know that you can add the numerators, yes? Okay, can I go further here? Yes?
Could you explain it once more?
Instead of 1, I wrote this.
Okay.
And then I have the same denominators. I put the denominator the same at the add the numerators. So that's exactly the same way that if I want to add 1 to 2/3. Yes?
Maybe you can factorize.
No factorization. This is on the board, yes? So I don't know. You see, this is a little bit of weakness. When I change the letter theta to x, then you get confused. And I told you letters are not important. The message behind formulas are important. So what is the English message behind this? How do you read this in English? Don't say sine theta is squared plus cosine theta is squared equals to 1. That's one way of reading, but that's not the message, yes? No. What you read for me is sine of an angle plus cosine of an angle is equal to 1. Is that one the same thing? Okay, so the plot thickens, actually. The problem becomes a little bit harder. So first, I will explain that one as well. But this is not the message, yes? Read it again. Because what I think you did in your head, you said that this and that are the same. And somehow you are thinking mathematicians are crazy. Why they don't take that 2's off? Yes? No, they are not crazy. Probably they are very precise people, okay? So if there is a 2, because be honest, mathematicians have this tendency to simplify things as much as possible. If they get stuck with the 2 in the formula, that 2 has to be there. If there is a way that they can get rid of it, they really want to get rid of it, okay? So I will come back to that point. But read this one in English. What is the message of that one? Anyone? Yes?
Sine of any angle squared plus cosine of any angle squared.
Not any.
Every.
No. Any, the first one, any,
The same angle.
the same, yes. If sine of any angle squared plus cosine of the same angle squared is always 1 regardless of the angle. Okay? So now, this is the message. You see, if you don't train your brain to think in that way, then you might to fall into some trap of factoring things and things like that, which is not necessary at all. So what is this one now? It's just 1. Yes? Sine of an angle, whatever that angle is, squared, plus cosine of the same angle squared is 1. So you don't need to do anything. Okay? You are actually done. So it's equal to 1 over cosine x squared. And even you don't need to explain. Whatever I have written here is completely enough. So just write it like that. Okay? Yes? And then this becomes equal to the right-hand side. Yes? Yes? Yeah. Yes? So is that clear? Yes.
Is it possible to prove it in a way that we get the sine of an angle squared plus cosine of the same angle squared equals to 1?
No, again, if you do that, you will get that one.
Yeah.
But you are telling that if this is true, then sine x squared plus cosine x squared is true. This is not correct, okay? So P implies Q. So we are saying that, you are saying that if this is true, then you prove to me that sine x squared plus cosine x squared is also 1. Okay? Yes? So it means that you see, when I am doing this, I am using this as a fact to prove that something I don't know. But you are doing the other way around. And then Q, this is mainly Math 5. And there are examples, in this case, that is working. But that's not always, okay? If you understand exactly, you explain everything correct, then of course I have to admit that, because that is also a quite good logic, yes? But if you prove P implies Q is true, there is no guarantee Q also implies P is true. We did this before with a very simple example. If x is 2, then of course x squared is 4. So if you tell me this, I can also be sure about this. But not the other way around. Yes, x squared is equal to 4 does not by itself guarantee that x is equal to 2. Okay? So it might happen that one of them is true, the other one is false. It might happen that both of them are true. Okay? So in that case, you have to be clear. Okay? But I just want you to understand that is not a healthy logic. Yes? Unless you start doing things in a step backward. In Math 5, we will study about this. This is called backward, backward logic or something like that. You take this, but I mean, any step that you take, you should make sure it is reversible. Yes? So that is important. Then you have to bring it in your proof. Yes?
We're doing this since it's identities, right? Because if it's equations, we can use the way down.
Yes. In equation, you can do that. Because in equation, you are looking to find something. Yes? Yes, that's correct. So might be, of course, here, if I ask you to solve it, you will tell me all x's except the ones that make the denominator 0 are the answers. Okay, but in solutions, yes, whatever you do on one hand, you can do the other hand. That's a good thing to understand. If you want to solve, then yes, you can multiply both sides by a number, you can divide them, yes, and then try to simplify it on both, because you are going to find one or some particular values for x that it works. Here we want to prove that this always works. We have to be more careful here. Okay, yes?
So for identities, can you simplify and use formulas and not multiply and divide stuff like this?
No, you can start from the left-hand side as an expression. If you don't have this one, whatever you can do for one single expression, you are still allowed to do. Okay? But if I give you a single expression, you cannot suddenly multiply it by 5. Because if one expression is multiplied by 5, this is no longer the old expression. This is the old expression 5 times larger. If you want to say something about this, you have to say something about this. Okay, you can multiply it by 5, but immediately you have to divide it by 5. Yes, for example, if I want to prove that 1 over square root of 2 is a square root of 2 over 2, okay? Let us take this as an identity. I want to prove this is true, okay? So I start from the left-hand side, okay? And I tell you that I cannot do like that because I am writing equality. I cannot write this, okay? Or I cannot, for example, do it like this because I won't say this is equality. But I can do something like this. If it is useful or not, that is another problem. If what I am doing is useful or not, okay? But then you see that I take the same, I want to say something about this. What I do, I say that this expression that I want to say something about it is 1 square root of 2 multiplied by 1, okay? And then I can say that 1 can be written as a square root of 2 over square root of 2, and then you know that this one multiplied by that one, square root of 2, square root of 2, 2, so the left-hand side is equal to the right-hand side. So I start from the left-hand side. I can multiply it by something, but immediately I have to divide it by the same thing so that I am not changing that thing. Yes? So, yes. So that's a very common mistake. That's very good that you're asking these questions. I want you to understand that there is a big difference between equations and identities. In identities, you usually have to start from the left-hand side, okay, and reach to the right-hand side. But in equations, you can start manipulating both sides. Whatever you do to the left, you can do the same thing on the right, and still you can make sure that it is working. Okay? Okay, another method is also possible. For example, let us say that I have an identity that both sides are complicated. Okay, that is possible. You take the left-hand side and then simplify it, and you get stuck at some point. And then you take the right-hand side, simplify it, and you get to another point. Okay? If you can prove these two are equal, then you are done. Because I was able to show that left-hand side is equal to this, the right-hand side is equal to this. If I can show that these two are equal, then left-hand side and right-hand side has to be equal as well. Why? Because A is equal to B, C is equal to D. If I tell you B is equal to D, what can you say about A and C? They are equal. So that is also possible. But it is different from starting multiplying things on both sides. So you can simplify the left-hand side on its own until it is until you cannot simplify it more. You can do the same thing for the right-hand side until you cannot simplify it more. If these two expressions happen to be equal, then it means that left-hand side is also equal to right-hand side. And the logic is that if A is equal to B, C is equal to D, and if you understand B is equal to D, immediately you can understand that A is equal to C as well. Yes? Is that correct?
Yes.
Okay. So let us try to solve more examples, because you have to have good experience of doing things. This is one of those parts that you have to practice more, and I will give you more extra problems so that you can work on. Let me solve another problem, for example, in the book. Let us see. Okay, before that, let me tell you that some people think that I want to make sure that if you also think in that way, please write it and cross it over. From here, some people think that we can write it like this. Okay? So this is not true. It might happen that coincidentally it is true for some particular angle, but that is not the rule. The reason that some people get confused about taking these 2's off is what? They think that, okay, I take a square root of this, and I take a square root from both sides, and I have this. Of course, the square root of 1 is 1, and a square root of this one is sine theta, plus square root of this one is cosine theta, and they think that this is the same thing as that. Okay, so this is wrong. Okay, if you also of that type that you think this is correct, please write it and cross it over once for all from your memory. Okay, but why this is not correct? What part of it was wrong? If this is true, of course this is true. A square root of 1 is also equal to 1. What part is wrong? So everyone agrees that this is right? What part is wrong? Yes?
The answer can be minus.
Pardon?
The answer can be minus.
Okay, so let us put plus or minus. Now you agree that this is true? If you say yes, that's a catastrophic yes. Okay? So don't say yes, please. But if you feel this is true, that's a very big problem. I told you before, I don't know, do you review the videos or something? I explained this before to you, yes? So, square root of a plus b and a square root of a plus square root of b, they are not the same. Okay? So you cannot write that. For example, if a is 2, let me take a to be 4, b to be 9. Square root of a plus b is what? How do you calculate this? What's the answer? So you write square root of 4 plus 9, but which one has the priority to be done here? So what's the answer? What? The square root of 30. Yes? But let me calculate square root of a plus square root of b. It becomes square root of 4 plus square root of 9. A square root of 4 is what? 2 square root of 9 is 3, so it is 5. And I hope that you agree that 5 is not equal to a square root of 13, because the square root of 25 is 5. So this is the matter of confusion. The reason that you are carelessly writing this, because you think that you can write this plus this. Yes, and then here you write sine and then cosine. Okay, but that was not correct. The square root of a sum is not equal to the sum of the squares. Okay, so be careful. Which one is correct? So you see that for these two, we don't have the correct formula. So these are not formulas, but these are. Of course, if A and B are positive. So if you see, the message is this. The square of a product is the product of squares. This is the message behind this formula. And here, the square of a division is the division of the squares. Okay? But the square of a sum is not equal to the sum of the squares. And the good point is that if it is not true, it is not true forever. Okay? So that's good. So these are formulas that are correct. A and B are positive, of course. Otherwise, this doesn't make sense. So be careful about that. This is not correct. Okay? So let me tell you something else. So for example, if sine theta plus cosine theta is 1, of course, you can see in some books they write different formulas. They move this to the other side. So sometimes you want to get rid of sine in favor of cosine. So remember, I can take sine squared out and write 1 minus cosine squared. This is not a new formula. This is the same formula written in different order. Okay? And of course, if I want, I can keep it like this, and I write it minus 1 sine squared theta. Yes? So these formulas are equivalent ways of writing the same formula. Okay? But some of you might think, so what is the correct one? If I want to find sine theta, what is sine theta? What is sine theta from here? Yes?
Square root of 1 minus cosine squared theta.
Yes? Can I write this as 1 minus cosine theta? No, because that's exactly the same thing that I taught. Yes? The square of the difference is not the difference of the squares. So you can stop here, but that is not complete. What should I write? I have to put plus or minus. And then the cosine theta is plus or minus the square root of 1 minus sine squared theta. Okay? So that is also equivalent to this one. So this is the very, so I want you to be flexible. Sometimes this is needed, sometimes this is needed, sometimes this is needed, so you have to know how to go back and forth between these formulas when necessary. Okay, let me give more examples now. So let us solve some problems from the book first. So the topic is the same. Do you remember I started an example, I had 2 parts, now I want to give part 3. But I will choose it again from the book. So part 3, let me choose this one. This is example 2217 in the book. Okay, so we are supposed to show that 1 over sine x squared minus 1 over tan x squared is equal to 1. So we want to show that the left-hand side, for all possible values of x, that this makes sense. I mean, if the denominator is not 0, then whatever x you choose, the difference between these combinations is always again equal to 1. But this is an identity. You can memorize it, but it is useless, yes? By experience, we'll realize that that formula up there is very important to remember. So this, we put it in the formula sheet. All the things that I am proving now can be put in principle in the formula sheet, but we don't need them because they are just problems, yes? It's not that important to remember them. Okay, so how should I do that? Let me again try to see what we do. The left-hand side is more complicated than the right-hand side. So I start from the left-hand side. Okay, what do you think I should do? We have to do something. What is that something that comes to your mind? By the way, you don't need to see everything until the very end, but you just need to take one natural step. What is that one natural step? Might be that's not very natural to you. You haven't practiced a lot here. But let us say that whenever you don't know what to do, take tangent off and write sine cosine. Why is that? Because we have a formula for connecting sine and cosine, but we don't have any formula to connecting a tangent to a number or something. So whenever, this is one experience from my side. If you really don't know what to do and you see there is tangent involved, take it off and write it in terms of sine and cosine. Hopefully, if it is a right combination, you get something similar to this, then you can use it. Okay? So what you do, you write 1 over. So now you have a strategy. Your strategy is to get rid of tangent. So don't manipulate this because you violate your own strategy. Your strategy is to get rid of that. So stick to your own. Okay? So what should I write? It is 1. Now you learned about, what can I write about this? Everyone, please. What should I write about tan x squared?
Sine x squared.
Sine, we just learned that, yes? Sine x squared divided by cosine x squared. Okay, then we continue. There is nothing that I can do apparently for this one. Okay, but this is a little bit unusual fraction. You have 1 over a fraction. 1 over fraction can be written simpler. Whenever you can write something simpler, just do it, okay? And hope for the best. So it means that I copy and paste this one. Okay, I want to see how many of you can do it immediately in a matter of milliseconds, yes? 1 over a fraction is equal to? Or 1 over 2/3. What is that? 3 over 2. 1 over a fraction is the reciprocal of the fraction. Is that understandable? Of course, I hope that you understand it quite well, because this means 1 divided by 2/3, and then you have 1 multiplied by, you swap them, and then it becomes 3 over 2. So you don't do that, yes? 1 over a fraction is the reciprocal fraction. So what can I write here now? 1 over a fraction swaps these. So it becomes what? Cosine x squared goes to the numerator, sine x squared goes to the denominator. Yes? And now what do you have? Your goal is to simplify. That is good. I have 2 fractions with the same denominator. So you cannot resist because you want to take the common denominator, yes? Yes? And then it becomes 1 minus cosine x to the power of 2. But this is still on the board, yes? 1, what is the message behind this? Sine of an angle squared is 1 minus cosine of the same angle squared. So 1 minus a cosine x squared can be taken off and replaced by sine x squared. Thank you. This is the numerator, yes? And the denominator is the same. But what can I write for sine x squared divided by itself? 1, yes? And what is 1? 1 is the right-hand side. Yes? But I think in the book they take 1 off. This is not necessary. That's up to you. They take 1 off. They write it sine x squared plus cosine x squared. Then say that this is positive, this is negative. They are gone. Sine x squared is left. Okay? So you really don't need to do these things. If it's hard for you, you can take 1 off and write this. But this combination, you need to train. So exactly like you know me, when you see my face, you recognize this is Babak, even if you see me in the metro station. That's the same thing. If you don't care, that's not, so you pass me and you don't understand even though I was your math teacher, yes? So this is exactly the same thing. I have trained my brain to say hello to this, okay, hello, so I know you, okay, how are you, something like that. So you need to train your brain. This pattern is ubiquitous in mathematics, in trigonometry. So whenever you see this, you say, I know this guy. So something like that. If you don't pay attention, so be my guest, you will not be learning mathematics. That's at least I don't know the way to learn. Okay? Okay, so remember, this combination is famous to you now. Whenever you see this combination with the message I told you, so this is, by the way, if I, for example, tomorrow I change my tie, you recognize me still, yes? That's exactly the same thing. So because you know me somehow. So you also need to know the messages of the formulas. So if you know the message of the formulas, then you say, that's the same thing. For example, what do you think about this? Please, only 1 second, okay? So what's the answer? 1. Because now you know that this is the same person who has changed the pants and shirts. Yet that's the same formula, yes? This is telling you that sine of an angle, who cares what that angle is, plus cos squared plus cosine of the same angle squared, you know that this is famous in trigonometry, it is 1. If you don't know this is famous, then you are in trouble. Okay, any questions here? I think we can solve at least one more. So that was problem 2217. Yeah, another problem is, let us do this one. It is problem 2218. So 1 over cosine x plus tan x multiplied by 1 over cosine x minus tan x is equal to 1. So we want to show that for any choice of x that these expressions are meaningful, the product of these two expressions is always equal to 1 again. So, okay, so what do you think we do? We start from one side, try to reach to the other side. And I start with the complicated side. So that is this left side, okay? Okay. Now I want to wait for you. What do you do now? Yes? Pardon? That is one way. If you want to do it, let us just do what you said, okay? That is not the way that I wanted to do. But I just want you to, if you do the correct things, it will work. Okay, so what you said, I will do it. So you are saying that, okay, instead of 10, I have one formula to put it in. Okay, and then hopefully the same thing you will do here as well, yes? Okay, then what? Yes?
I know that 1 minus sine of.
No, that is not correct. Yes. So you can combine them if you want to. Why do you stop? You started, yes. Let us go a little bit move on. So what can I do now? Yes? Yes, it was better to start from the conjugate. Okay, but we missed that. Okay. Okay, so you are right, because I wanted to start with the conjugate myself. Okay, but he actually deviated the problem, but I want to show you it will work. It is not, you don't need to choose exactly what I wanted to choose. Okay, but here, before, so if you say conjugate, let us do the conjugate. Yeah, no worries. Do you see there's a conjugate pattern? Yes? What is the message behind conjugate pattern? If you don't have the message, you will not understand that. So the conjugate pattern, I'm sure that when I write it in that way, you can answer it. But if I write it in that way, you get confused, and not many of you can see it. Here, 99% probably can see, but here they cannot see. The reason is that you just see the formula without the message behind the formulas. This tells you that if you have two numbers, once subtracted, once added, and you are interested in multiplying them, there is a rule behind that. Raise the first one to the power of 2, raise the second one to the power of 2, and subtract it. Okay, so that's the same message here. You see, I have this number and that number are the same. These two numbers are also the same. I am interested in adding them once, subtracting them then, and then multiply them. So that's the conjugate rule. Yes? So the conjugate rule tells you what? It becomes the first one squared minus the second one squared. This is the conjugate rule. Okay, but so you know that there are some things that we have to clean in the middle. So here I have a fraction to power 2. So you can write it simpler. How? If I have a fraction to power 2, I raise the numerator to power 2. 1 to power 2 is just 1. I raise the denominator to power 2, which is this. Yes? And then you just learned about that as well. So this is sine to the power of 2, cosine to the power of 2. Okay, what should I continue now? Yes?
Now I know that 1 minus sine.
So we have the common denominators. Don't jump ahead. So here we have the common denominator. So I put the common denominator, and I know that I can subtract the numerators, yes? Again, this is a familiar guy in trigonometry. 1 minus sine x squared can be replaced by 1 minus sine x squared. Here I have written theta, but you know the message. 1 minus sine squared of an angle is equal to the cosine squared of the same angle. So this I can be replaced this one with what? Yes, is that understandable? And then I copy and paste the denominator. But what is this one? Just simply 1. And that is exactly equal to the right hand side. Yes. So that's good. Understandable? Okay, so let me solve one more. So let us solve the problems in the book. I can give you more examples if you want to practice later. Okay, so let us solve mainly the good problems in the book. So number 4. So let us choose this example. It is 2219. Okay, so the problem is we are supposed to show that cosine x to the power of 3 multiplied by tan x to the power of 3 again, no, to the power of 2 plus cosine x to power 3 is cosine x. Yeah, it is very strange. Let me see. Yes, apparently it is right. Okay. So you see, I have a left-hand side, I have a right-hand side. I will start from one side, try to manipulate it so that I can reach to the other side. And I told you that as an experience, I know that starting with the more complicated side is better. Okay? So take this advice. So then it means that we start from the left-hand side. Okay, now I want you to tell me what to do. Yes? Yeah, and the same formula for tangent. Yes. It is good. First of all, if you don't know, usually this is a good advice to follow. The second thing is that on the right-hand side, when you look at it, you don't have any tangent there. So you have to get rid of tangent, yes? Because tangent shouldn't appear on the right-hand side. Okay, so it means that your strategy is to replace this with its formula. So it means that you have to stick to your strategy. Don't be in a hurry, okay? Just copy and paste the parts that you are not going to touch. And then what you write this one is sine x squared cosine x squared. And then you copy and paste the rest because that was your strategy for the time being. Okay? So you write it like that. Okay, then what? Yes? Yeah, exactly. I hope that everyone understands. If I give you, for example, a to the power of 3 and multiply it by, say, b to power 2 divided by a to power 2, do you agree with me that two of these a's can be cancelled with two of these a's? One a will be left. So I will do the same thing here. This is the same number here. I have the cubic power, I have the second power, so two of them will be cancelled with them, and one cosine will be left. Yes? Is that right? Okay. The next step is to get rid of this mess. Okay? Clean it up. So what should I write? Cosine x is left for me. If you want, you can put the dot or remove it. That's up to you. And then you have sine x to the power of 2. Do I really need to put 1 here? No, because anything divided, by the way, when I say I divide, 1 is left. But you don't need to put 1. Every number divided by 1 is itself. And then you copy paste the rest of them. Okay, then what? Yes?
Factorized cosine.
Yeah. Because first of all, I told you, don't get this connected with the right-hand side. On the right-hand side, what do you need? You need cosine. You have some cosines involved there. But you can see that there is a cosine x that I can pull out, yes? Okay, if I factorize cosine x out, it means write something here so that when you multiply cosine back, it gives you this. So what should I write here? Sine x squared, then plus, what should I write here? I need something so that when you multiply this back, it gives you the third power of cosine. So what should I write here? Cosine x squared. Yes? And hopefully now this looks familiar. Yes, sine x squared plus cosine x squared can be replaced always with 1, and then we are done. Cosine x times 1 is what? And that's equal to the right-hand side. Yes? Understandable? Okay. So, when the lesson ends, do you know? 11:30? Okay, so 11:30, let me solve the next one. It's a little bit harder. So number 5. This is a problem 2220. Yes? We want to show that cosine alpha to power 4 this time minus sine alpha to power 4 is equal to 1 minus 2 sine alpha squared. So this is a little bit hard. So we want to show that for every choice of alpha, if someone calculates this or someone calculates this, the answers are always equal. Okay. Do you have any opinion what to do? There is one simple way to do it, simpler way, but there is something that usually, if you have listened to me, you should be able to discover it yourself. Okay, first of all, let us start from the left-hand side. Let me copy and paste the left-hand side here in front of our eyes. Yes? Okay. You see that here you have a mixture of sine and cosine. But when you look at the right-hand side, you don't have cosine. You have only sine. So it tells you something. It tells you to get rid of cosine. Yes? Somehow. But in a legal way, okay? Yes? So how should I do that? Yes? What do you mean if I factorize? For conjugate rule. Yes, that is the easiest way. Yes. So what she's saying is that it's not on the board anymore. So do you remember I told you that a minus b times a plus b is equal to a squared minus b squared. So you see, this pattern is ubiquitous in mathematics. You need to remember this pattern. You should also remember this pattern, the difference between two squares. Yes? So if this is given, sometimes this is given, it is useful to write it like this. Sometimes this is given, it is useful to write it like this. By solving more problems, you get experience which one is the good alternative. So for example, here, do you think which way is useful? From left to right or from right to left for the purpose of this problem? Right to left, yes, because this is power of 4. But every power of 4 can be viewed as a power of 2 if you just write it a little bit different. How can I write it in my head? I can say cosine to the 4th power has another name that is useful because if I want to use that. Do you agree, first of all, what I have written here is exactly the same thing? Yes. And then another one, hopefully you realize that I can do the same thing. You might say that why should I change this to this? If that pattern is not familiar to your eyes, there is no way to answer that. But if you have that pattern in mind, then might be you understand you can do that. But now, in that formula, this whole thing is playing the role of capital A, then I have A squared, and this whole thing plays the role of capital B, then I have B squared. So I have a squared minus b squared can be written differently. I can write it as what? The multiplication of 2 pairs of brackets. So the first pair of bracket is a, which is cosine alpha squared minus b. And I don't want you to explain this that much. I really prefer you to do it as fast as you can. I hope that you can immediately see that this expression can be factorized in that form. Is that right or not? Yes or no?
Yes.
But could you see why this is useful? Because suddenly the familiar guy appears. Yes? Sine of an angle to power 2 plus cosine of the same angle to power 2. You know what is the answer to this guy. What is that? 1. So you just write 1. And you multiply here, it becomes cosine alpha to the power of 2 minus sine alpha to power 2. Okay? So first of all, I would say this is a successful attempt because the 4th powers reduce to 2nd powers. And in mathematics, 2nd powers are easier to work with than 4th powers. So it is a good thing to do. But unfortunately, it is not finished. Because what I want to do, I want to show that it is 1 minus, I want to show it is 1 minus 2 sine alpha squared. Still, I have a mixture of sine and cosine. So you need to get rid of cosine in favor of sine. And again, this is a very standard trick. If you don't send it to your memory, you will be in trouble over and over again. You have cosine squared. You don't want it. You want sine squared instead. So you have to get rid of cosine squared in terms of sine squared. So what is the formula? Can you tell me what is the formula? Yes, please.
1 minus sine.
Yeah, exactly. So anyone, if you have trouble, please let me know. Do you understand that? Do you remember? We have sine alpha squared plus cosine alpha squared is 1. I can move this to the other side. So cosine alpha squared is 1 minus sine alpha squared. Yes? So instead of cosine alpha squared, I can write 1 minus sine alpha squared. Yes? So, and then I have another minus sine alpha squared. But do I really need this pair of brackets? No, because there is no sign behind that. So let me clean it. And then can I continue further? This is a number. So let me write. What is your opinion about this? If in Math 1C I give you this, what is your answer? Yes, 1 minus 2x squared, yes? That's the same thing. But instead of x squared, you have sine alpha squared. So it becomes 1 minus what? What?
2 sine.
Minus 2 sine alpha squared. And this is exactly the right hand side. Yes? So you started from the left hand side and reached to the right hand side. Okay, so I think it's a good idea if I stop here. But I will provide you with more exercises. This is one part that you have to practice a lot, but it's not that hard that it seems. Okay,